So here we have a package unit. So the indoor unit and the outdoor unit is all in one package. It's still going to be the full refrigeration cycle. What we're going to do is take this top off so we can look at everything and go through that refrigeration cycle. So here's our package unit with the top completely off. Now we still have an indoor section and an outdoor section. This is going to be our indoor section. We have our evaporator coil and our blower motor, and this is touching the air on the inside. On the outside, this is all exposed to the air on the outside. We have our condensing coil and a compressor out here. So this is our outdoor section. So even though it's split, it's in one giant package, it's still split up. Let's talk individually about how this system is going to work. If you look on this side, we have our evaporator coil, and below that there's going to be a hole in the ground. Well, if this is on the unit, that would be attached to ductwork, and this would be called the return air. It's returning air to the unit. It's pulling air from the building through the filters across this evaporator coil, which is absorbing heat, and it's being pulled by the blower. The blower then forces that air back down into the building. If we were to take this blower off, there'd be another hole going back into the building. That's called supply air. So it's pulling air through the evaporator coil and back to the building. What it's doing is absorbing heat out of the air, blowing the cooler air back into the building. When we reject heat, we're rejecting heat on the outside. So this is my outdoor section. There's a fan motor here, and it's pulling air through the sides and up to the top. As it's doing that, it's taking the heat out of the refrigerant and going to the air. So we're warming the air up and we're cooling the refrigerant off. This particular unit had some very special things on the side of it. These are called hail guards. They go on the outside of the unit, and when there's a hailstorm, for example, like West Texas, it'll damage these coils very easily. So this helps prevent those ice rocks from damaging the unit. So let's go through the refrigeration cycle, and we'll always start from the compressor. Now ideally, you've been practicing drawing a refrigeration cycle, and if we can do it on paper, it's the very same thing that's going to be on the actual unit. So we're going to start from the compressor. On this particular unit, our compressor is located right here, and it's also called a vapor pump. Sucks in low pressure vapor, pumps out high pressure vapor, moves the refrigerant. So our compressor pumps out high temperature, high pressure, superheated vapor. This is the discharge line, also known as a hot gas line, the shortest line in the whole entire system. We have a pressure port where we can get the high side pressure, but this is high temperature, high pressure, superheated vapor. From there we go into our condensing coil. So this is our condensing coil, and our condensing coil does three things. The first thing it does is de-superheat the refrigerant. That's sensible heat, that's very little heat, just the first little bit of this refrigerant cycle. Then the majority of this unit is going to be saturation. It's going to change state from a vapor down to a liquid. It's rejecting heat. All of this is going to be about the same exact temperature because it's latent heat. It's going to be a change of state without a change of temperature. This is where most of your heat transfer is coming in place, and this is also saturation. Now after we change it completely into a liquid, we then want to subcool that liquid. The very bottom little bit of this condensing coil, that is going to be for subcooling. We can measure that. It's below saturated temperature. So our subcooled refrigerant leaves that condensing coil, and we end up going into this liquid line filter dryer. So it leaves the coil and goes right into our liquid line filter dryer. Has an arrow pointing this direction, and this is it filters the refrigerant and dries any H2O out of the refrigerant, which there shouldn't be any. But our liquid continues over, we continue down, and now we go in towards our evaporator. Now this particular unit has a very unique type of metering device that you won't see anywhere else. If we clean this up right here, there's multiple little crimps right here, and this is a header tube, and each one of these little crimps is a fixed orifice metering device. This particular unit has 1, 2, 3, 4, 5, 6. This has 6 different metering devices, so it's feeding a refrigerant in multiple places in the unit. You cannot access these, and they're really a pain to change, and it's the thing about this brand that I hate the most. Anyways, the refrigerant, then this is the metering device, so it changes from a high pressure liquid to a low pressure saturated mixture, approximately 75% liquid, 25% vapor. That vapor is called flash gas, into the evaporator coil. So now our evaporator coil, most of this evaporator coil is going to be saturation. It's going to be changing state from a liquid to a vapor. It's going to be absorbing heat. That's latent heat. So most of this evaporator is going to be the exact same temperature, pressure converted to that temperature. And after we boil all that refrigerant to a vapor, the very last little bit coming out of this will be superheated vapor. Superheat being measurable heat above saturation. So our superheat is going to come back. All these individual tubes will connect to one large header, to one suction pipe. The suction pipe, also known as a suction line, gas line, is a low temperature, low pressure, superheated vapor. This suction line continues all the way back to the compressor. This is a refrigeration cycle. Now there's some keys on this. If I'm going to check superheat, I'm going to put my gauge here and my temperature clamp here. It's going to be the actual suction line temperature minus suction saturated, PSIG converted to temperature. If I was going to check subcooling, it's a little bit more tricky. I'm going to put my gauge here, but this is a superheated vapor line. But as long as I get my pressure, it's telling me saturation in the coil. So it's not happening right there. So I'm still going to get this pressure converted to a saturated temperature. So it's liquid saturated temperature minus my actual liquid line, which is going to be over here. If I find my filter dryer, we'll see that this is my liquid line coming out of my filter dryer or going into my filter dryer. Either one of these temperatures would be my actual liquid line temperature. So it's liquid saturated, PSIG converted temperature, minus my actual liquid line. This is my subcooled liquid line. So that's where we would get our subcooling. Subcooling is representing what's happening on the outdoor section, and superheat's representing what's happening over here on the indoor section. So even though it's a package unit and the whole entire mechanical piece is outside, we still have an outdoor piece and we have an indoor piece.